Hello friends, I am Prashant Gadak. Today I am going to deliver a lecture on computational complexity. Dear students, in computational complexity, we know that computational complexity is a very basic part of theory of computation. So what happened in theory of computation? In theory of computation, we learn different languages like as formal language as well as context-free language. So in TOC, this language deals with how to accept the language or how to generate the language. So before starting with computational complexity, here I want to ask you one question. Our computer science engineering deals with. So if I asked what computer science engineering deals with, the answer is computer science engineering deals with problem, because from first year of engineering we learn fundamental programming language, then data structure, advanced data structure, our database management system, theory of computation up to the compiler design. But each and every time we are worried about problems, means our target is how to solve the problem and how to find out the solution for the problem. So the problem concept is come into the picture in 1970. What happened in 1970? The scientist having name is Euler was introduced a concept having name is problem. This problem have two types. The first one is solvable problem and second one is unsolvable problem. So what happened? Just consider a simple example. If I asked to you people what is 2 plus 2, you can quickly give answer, sir, 2 plus 2 is 4. How? By taking some mathematical background, by taking some algorithm help, you can easily say that, sir, 2 plus 2 is equal to 4. But if I ask question what is 2 divided by 0, you will require some time. After taking some time, you can easily say that, sir, 2 by 0 is a divided by 0 error, is a divided by 0 error. So some problem are solvable and some problem are unsolvable. On the basis of this solution, problems are categorized into different classes like as P class, second one is NP class, next one is NP hard class, and last one is NP complete class. NP complete class. Now what happened? Each and every keyword consists one common alphabet, that is P. What is meant by P? P is nothing but polynomial time. P is nothing but polynomial time. Here the new concept is come into the picture, that is polynomial time. So first upon we will see what is polynomial time, then we will see what is P class, NP hard and NP complete. So the first one is polynomial time. Polynomial time. So what is meant by polynomial time? Polynomial time is nothing but reduction. Is nothing but reduction. So what is reduction? Just consider a simple example. If we have one machine having name is Turing machine. If I have one machine having name is Turing machine, this Turing machine is generate a two language, that is L1 and another one is L2. This L1 is belongs to some input alphabet. Similarly, L2 belongs to some input alphabet. If we apply some function on the Turing machine, that is F, this Turing machine is generate X function in L1 language. This Turing machine generate F of X function in L2 language. So here the conclusion is L1 is reducible L2 and L2 is reducible by L1. So this is indicate that we can solve a problem at polynomial time for the language L1 as well as language L2. If we can consider another example, suppose if we have a problem, but this problem don't have any solution. This problem don't have any solution, and if we want to find out the solution for this problem, just need to check another problem which have solution. Suppose consider another problem which have a solution, that is the B problem. Means we can reduce a problem B from the problem A at polynomial time. So this concept is called as polynomial time. Now this concept is come under P problem, NP hard and NP complete. So we will see what is P problem. What is P problem? Now see here, again in problem the question mark is problem, because we are dealing with problems in computer science of engineering. So if we want to solve the problem, we require some algorithm as well as we require some time. Means here we are thinking about time complexity and here we are thinking about algorithm. So consider a simple example. Suppose example is searching technique. Example is searching technique. If I have one array with consists some element like as 1, 2, 3, 4 up to the 9, and if I ask a question to find out the element 4, at that time the time complexity is big O of n. So what is this? This is the polynomial time complexity. General polynomial time complexity is O of n raised to k. Here k is a constant. Means if in searching technique the value of k is 1, means that's why I can say this k is a constant, and this is a polynomial time complexity. Means if you can take searching algorithm, sorting algorithm, the complexity is always polynomial time. So such kind of problem are called as P problem. So the example of P problem is always searching, sorting, etc. The next one is NP problem. NP problem are always solved at non-deterministic machine, and this P problem we can solve with the help of deterministic machine. Here I already explained, we just consider example as a Turing machine. In Turing machine we can solve polynomial time problem as well as we can solve non-polynomial time problem. If the problem is polynomial time, or you can say if the problem is P problem, we can use a deterministic machine. But if we want to solve a non-deterministic polynomial time problem, at that time the required is non-deterministic Turing machine. So now the next concept is, what is NP problem? Again this concept is very simple as compared to the P problem. What is NP problem? NP is nothing but non-deterministic polynomial, that is we already cleared. So in NP problem, this non-deterministic is indicate the guess. This non-deterministic is nothing but guess, means we have some prediction. If I have a problem, that problem always have more than one solution. Suppose I ask question, you want to go from college to library, how many solutions are there? You can easily say, sir, there are two solutions, one from with the help of lift and second one is via a staircase. So there are two solutions, means in non-deterministic polynomial time problem there are solution having probability is yes, or second one is no. So such kind of decision problem is always come under non-deterministic polynomial time. So in non-deterministic polynomial time, again the complexity is polynomial, and we know what is the complexity of polynomial. The complexity of polynomial is big O n raised to k. Again this k is a constant. What is the difference between P problem and NP problem? Just a simple, we can solve a P problem at a polynomial time but by using deterministic machine, and in NP problem we can solve a problem at polynomial time by using non-deterministic machine. So consider a simple example. Again suppose I have one array, with array consists 100 number, that is 1, 2, 3, 4, 5 up to the 100. So what happen if I ask question, find out the two number in given array having addition is equal to 100. Suppose I consider a first element x, means we can store first element in x variable, we can store second element in y variable, and my target is x plus y is nothing but 100. So here we want to find out a two number having addition is equal to 100. So here solution is possible or solution is not possible, means again prediction are happen. That's why this problem is called as decision problem, and we know decision problem is always come under NP problem. So this is called as the non-deterministic polynomial type problem. The next concept is NP hard. Now see, NP hard, this name suggests that this concept is little bit hard. This concept have hard solution. And in this concept we can't think about feasibility. Means suppose we have a problem statement, we can't say this solution is feasible. This technique is come under NP hard. And what about NP complete? We will see with the help of simple diagram. Just consider this simple diagram. Suppose I have one problem which is come under polynomial time, or you can say it's a P class. Another class is NP class. Another class is NP class. If I draw this circle having name is NP hard, and this common portion is called as NP complete. Now see here, what is meant by NP complete? This NP hard is always reduces NP complete. Why? Because NP complete problem is come under NP as well as NP hard category. So NP complete problem is always reduces from the NP hard, and such kind of problem we can say it's a NP complete problem. Finally, the conclusion is, whenever you people are selecting a problem statement for your project purpose in final year of computer engineering, at that time we people are just checking the feasibility of our problem statement. We can check feasibility of problem statement with the help of idea matrix and knowledge canvas. After checking the feasibility, our main target is to check our problem is come under which category, or you can say which class. At that time, just use this technique and find out your problem is come under which category. But 99% problem is always come under NP complete category. Why? Because NP complete problem is always come under NP as well as NP hard. That's why maximum problems are come under NP complete. Thanks.